furnace. This is a core type or low frequency furnace, and second is coreless type or high frequency furnace. Now this core type may be direct core type, it may be vertical core type, or it may be indirect core type furnace. So let us discuss all these types of induction furnace one by one. Now first of all, basically what is induction heating? It consists of an iron core, crucible and primary winding connected to an AC supply. So I will show you the diagram first. So this is an iron core, this is a crucible, and this is the primary winding. This is the primary winding, this is the secondary winding. The charge is kept in the crucible, which forms a single turn short circuit secondary circuit. Now in that crucible we have added the charge which we want to heat. So this will give us a single turn secondary winding. The current in the charge is very high, in the order of several thousand amperes. So the charge is magnetically coupled to the primary winding. Now because of that high current, the charge is melted. Now when there is no molten metal, no current will flow in the secondary. So to start the furnace, molten metal is poured into the oven from the previous charge. Disadvantage: the magnetic coupling between the primary and secondary is very weak, therefore the leakage reactance is very high. Now this causes the low power factor. Now since low frequency supply is necessary, because the normal frequency causing turbulence of the charge, because and this problem is known as pinching effect. So this will we discuss in next slide. So this is the first category, that is the core type induction furnace. Now see, this is a iron core, this is a primary winding. Now this is a crucible in which we have poured the charge. The charge is that material which we want to heat. Now this charge will give us single turn secondary winding. So the core type furnace consists of an iron core, crucible of some insulating material, and the primary winding connected to an AC supply. Now the charge to be heated is kept in the crucible, which act as single turn short circuit secondary. The charge in the current in the charge is very high, of the order of several thousand amperes. So due to this high current, electromagnetic forces are set up in the molten metal, now which result in pinch effect. So this may cause complete interruption of the secondary winding. Now this pinch effect depends upon the frequency. So as the frequency increases, pinch effect increases. So we must keep the low frequency for the direct core type induction furnace. Now so for the low frequency, we must have separate generator set to obtain the low frequency. So drawback is leakage reactance is high, therefore the power factor is very low. The second is low frequency requirement. So extra DC generator set is required, and it suffers from the pinching effect, and it is preferably used for non-intermittent service. The second type is vertical core type Ajax vat furnace. Now here now in the earlier method, that is a direct core type furnace, in that we have a problem of pinching effect. So in this category, that problem is reduced, is eliminated basically. Now in vertical core type furnace, first of all see, this is a primary winding, this is a secondary V channel, this is a refractory channel in order to avoid the loss of heat. Now this is a charge which we want to heat. Conventional, this is a direction of conventional current. Now here the charge inlet. Now here from here we will pour the charge into the channel. It is a modified type of the core type induction furnace. It has a vertical channel for charge, thus the crucible used is also vertical. The principle of operation is that of a transformer in which the secondary turns are replaced by a closed loop of molten metal. The primary winding is placed on the central limb of the core. Hence, the leakage reactance is comparatively low and therefore the power factor is high. The top of the furnace is covered with an insulated cover which can be removed for charging. Necessary arrangements are usually made for tilting the furnace to take out the molten metal. Now, when primary is connected to AC supply, high current will be accumulated at the bottom and even a small amount of charge will keep the secondary completed. So, hence the pinch effect can be removed and hence the chances of discontinuity of the circuit is very less. So, advantage of this furnace is it has high efficiency and low operating cost. Since both primary and secondary are on the same central core, its power factor is better. The furnace is operated from the normal supply frequency, that is no any requirement of generator set for the low frequency, and it is used for melting non-ferrous metals like brass, zinc, tin, bronze, copper, etc. The next is indirect core type induction furnace. Now here the charge is not in direct contact with primary and secondary winding. Now in such furnace an inductively heated element is made to transfer its heat to the charge by radiation. It consists of an iron core linking with the primary winding and secondary. When the primary winding is connected to the supply, current is induced in the secondary of the metal container. So the heat is produced due to the induced current and this heat is transmitted to the charge by using the radiation process. Now next is coreless type induction furnace. Now see, this is a container. Here this is a primary winding. Now this is a charge which we want to heat. Now in coreless induction furnace also operate on the principle of a transformer. In this furnace there is no core and thus the flux density will be low. Now hence the compensating the low flux density, the current supplied to the primary should have high frequency. Now stirring of the metals take place by the action of the electromagnetic forces, and to prevent the primary winding from high temperature, refractory linings are provided between the primary and secondary winding. Now here the high temperature is obtained in the coreless induction furnace. So see, it main consists of three parts: primary coil, ceramic crucible and the frame. There is no any iron core. Primary coil is fed with AC supply. Now eddy current is induced within the charge. Now this eddy current produces heating of the charge and therefore high frequency supply is to be used because of the low flux density. Now high frequency increases the resistance due to skin effect, resulting in high primary copper loss. Advantage of this coreless type induction furnace is time taken to reach the melting temperature is less, accurate power control is possible, any shape of crucible can be used, the eddy currents in the charge results in automatic steering, absence of dirt, smoke, noise, etc., and the erection cost is less, and it is used for the steel production, melting of non-ferrous metals, and it is used in electronic industry. And last category of the high frequency heating is dielectric heating. Basically this heating is related to the heating of non-metallic material, that is the insulators. Now see, dielectric heating is also sometimes called high frequency heating. Now if a non-metallic materials, that is insulator, such as wood, plastic, china clay, glass, ceramics, etc. are subjected to high voltage AC current, their temperature will increase. Now increase in temperature is due to the conversion of dielectric loss into heat. Now the dielectric loss is dependent upon the frequency and high voltage. Therefore, for obtaining the high heating effect, high voltage at high frequency is usually used. Advantages of dielectric heating: it gives us uniform heating. Second is its running cost is very low. Non-conducting materials are heated within a short period and it is very easy to control. Now applications: it is used for food processing, it is used for wood processing, it is used for drying purpose in textile industry, and it is used in electronic sewing purpose. The next is requirement of a good electrode material. Now the material, that electrode material must have the following properties, that is, it should be good conductor of electricity, it should have high resistance to thermal shocks, it should have sufficient mechanical strength, it should have low thermal conductivity, it should be insoluble in charge, chemically inert and non-corrosive. So electrode material, the choice of electrode material depends upon the temperature for which we are using that material. The first is for the low and medium temperature up to 1150 degrees centigrade, we use the alloy of nickel and chromium, in which nickel percentage is 80% and the 20% is chromium. Or we can say that we can use alloy of nickel, chromium and iron, in which nickel percentage is 65, chromium is 15 and iron is 20%. Now for the high temperature, this electrode material, the electrode must be made up of silicon carbide, molybdenum, tungsten and graphite. Thank you.